Good evening, folks. Welcome to the Tyne and Humber branch John O'Neill Otter Trophy New Generations Competition 2022. We've got four speakers this evening who are going to tell us about some interesting projects. First of all, I just wanted to go through some housekeeping things for the session. So I'll move on the slide. So general housekeeping then. This event is going to be recorded. We'll only put the recording onto the website if the speakers give us permission and there are no copyright issues. If you experience any technical problems with the Zoom Zoom call today, please use the chat feature to let us know what those technical problems are, and Barbara, who's on the call, should be able to assist with that. We've got the Q&A feature in Zoom here, so if you have any questions for the presenters, please type the questions into the Q&A. We'll then, at the end of each of the four presentations, we'll review the questions and ask the speakers to come back to us with those. And yeah, there's 2 hours of CPD attributable to this webinar. Okay, so a little bit about CIWEM as well, whilst we're here. CIWEM, hopefully people know, we are a chartered professional body and an independent charity, and we're working towards a safer and more sustainable world, building a global community of water and environmental professionals. And we've switched into a virtual world, which is helping us reach out to a wider and global audience now. A few things that CIWEM are promoting at the moment is the Climate and Ecological Emergency Declaration. So CIWEM made this declaration at the end of 2019, and we're holding events that address the issues arising from the declaration, linking in to COP meetings taking place this year. So there's COP 26 from Glasgow last year. There's a UN Convention on Climate Change, and there's Climate Emergency COP 27, which is taking place in Egypt in November this year, and COP 15, which that's already taken place in May earlier this year. So other events coming up with CIWEM, we've got on the 2nd of August the CIWEM AGM, and on the 3rd of August we've got the Wilder Carbon Project event, which is being hosted by the Southeast branch. So without further ado, I'll move forward into this evening's event. So we've got a judging panel here. So I'm Richard, I'm the current chair of the branch, and we've got 3 judges who are going to be listening into the presentations, who are Rob Berry, who is the treasurer, we've got Anna, who's on the committee, and we've got Mike Watson, who is the honorary secretary. And the 4 finalists that we've got presenting this evening are Joshua Dean, who's an assistant flood risk technician from Tetra Tech, talking about surface water consenting on high-speed 2 structures in the floodplain. We've got George, who is a graduate flood risk technician also at Tetra Tech, and he's talking about hydraulic modelling to investigate flood risk management solutions for a lost river of Sheffield. We've got Josh, another Josh, who's from RPS. He's going to be talking about exploring catchment-wide implications of flood mitigation optioneering. And then we've got Katerina, who's a assistant flood risk consultant from Tetra Tech, talking about the Wisebeck flood risk assessment. So I'll hand over to Josh at this point. So Josh can talk to us about surface water consulting. So I'll stop sharing screen.
Yeah, and thanks for that, Richard. Hi everyone, Josh here. I'm going to flick my camera on now, but when I'm presenting I'm going to have it off, just so I can get my screen up properly. I'll just start sharing screens now. Sorry, it started sharing the wrong one. That should be fine. Can you see that okay? Is that okay?
Yes, we can. Thanks, Josh.
Perfect. Yep, so as it says there, I'm Joshua Dean. I'm an assistant flood risk consultant for Tech. Been at Tech for the past year. Prior to this, I was an FCRM officer for the Environment Agency in the asset performance team. And prior to joining the EA, I studied my bachelor's in environmental science at the University of Leeds. I'm a graduate member of SciWem, and I've just listed below my areas of expertise. So flood risk assessments, consenting, which I'll be touching on today, and asset management as well. So as Richard mentioned, my presentation, I have slightly amended the title, apologies for that, but it's Surface Water Consenting on High Speed 2, and I'm going to be talking about a case study of a consent for a viaduct for the HS2 alignment I was involved in. So I've named this Viaduct X, so I'll refer to that as Viaduct X today, sorry. So I'll just run you through the contents of my presentation now. So section 1, essentially just a brief overview of how I am involved in the consenting process on HS2 and what we are consenting on. Section 2, introducing the viaduct and how I was involved in the consenting process for the viaduct. And section 3, essentially exploring the outcomes and results of the case study of the viaduct itself. So section 1, introduction to surface water consenting on HS2. So I've been part of the consent team on this part of the alignment of HS2 since last October. I've been consenting on about 75 kilometres of the alignment starting from the Chilterns, northwest of London, to a village called Southam. The alignment crosses a number of main rivers, which you can see from the statutory main river map on the right-hand side. And I've listed a few of the key main rivers in the bottom left I've been working on. But I also must mention that we also consent on the ordinary watercourses as well, which this main river map doesn't show. But as you can imagine, there's also quite a few ordinary watercourses on the alignment as well. So I'll just run you through now the different sorts of packages I'm involved with for consenting on high speed 2. So probably starting off with the most simple sort of package is for drainage outfall. So this could be a drainage outfall draining from the HS2 track itself, or the embankments and the cuttings associated with the track and discharging into watercourses. Also drainage culverts conveying the same sort of drainage. Watercourse diversions are a bit more complex. That looks at where we're having to actually divert the watercourse due to the HS2 alignment or structures associated with HS2. Flood compensation areas, we have to consent for them as well. So that provides mitigation for any increased flooding from HS2. And structures in the floodplain, so any sort of structure associated with the alignment which takes up any amount of floodplain. So as I said earlier, I'm going to be talking about a viaduct, so that's why I've highlighted that red there. So that's an example of a structure in the floodplain, a viaduct and its piers. Also access roads associated with the alignment and any of the embankments and cuttings as well. So section 2 is the case study of Viaduct X. So I've been leading on this consent, which comprises an 880 metre long viaduct, which crosses a main river on the HS2 alignment. As it crosses a main river and its pier footings either side of the channel are in proximity of the channel itself, it requires consent from the Environment Agency. So just to give a bit of a context on the area, the viaduct itself is already on the EA's radar as a hotspot of contention, mainly due to the issues surrounding the proposed design and also the scale of the viaduct and the size of the river as well, as it's a well-established river at this point. The latest design, sort of the arrangement of the piers in relation to the channel are shown in the second figure. So as you can see from this figure, the piers actually don't impact upon the channel itself, so no diversion is required as part of this consent. However, I've just circled on each pier footing where there is a slight encroachment into the banks of the channel. So Environment Agency requirements and concerns. So I identified that the EA's concerns were mainly surrounding scour potential from two factors related to the design. So I've listed them in the top left. So we've got the void space between the piers. So as you can see in the first image in the middle, there's a significant amount of void space, which does create an area of potential scour. And then the angular sort of pier shape of the pier footings also may provide a greater structural benefit, but again, the EA flagged that these piers can actually be more prone to causing scour due to their shape, essentially. So following this, I used my knowledge of the Water Framework Directive to identify that the scour potential from our current design could actually be detrimental to the WFD status of the water body and also to flood risk in the area. So I reviewed the water body status and I found that the water body was assessed as having a yellow impact as defined by the Water Framework Directive. So a yellow impact from HS2, I basically define this on the left. So this would be a minor, localized and or temporary effect when balanced against likely embedded mitigation. And it is insufficient to affect an element at a water body scale. So essentially I need to ensure as part of my consent and the design, which is reflected in my consent, that the status of the water body isn't impacted any more than yellow, and also to keep in mind flood risk as well. So communication with design teams. So to resolve the issues I've mentioned earlier and gain eventual consent from the EA for the viaduct, I had to host a series of discussions to present the EA's issues to the design teams. So this required communicating with a range of different disciplines of design. So I've listed the key ones here. So we've got structures, scour, geomorphologists, and ecologists. And I facilitated these discussions between the design disciplines to essentially satisfy the EA requirements, but to also ensure WFD impacts were negated, and to also ensure HS2 tech standards were adhered to as well. Sorry, my slide's sticking a little bit. Oh. Sorry, it's not wanting to move on. I'll give it a second to load. I think I've frozen. Hello? Am I still in the call? I can't quite see.
Oh yes, Josh, we can hear you, Josh, but we're on communication with design team's slide at the minute. Maybe you need to sort of stop sharing it and share it again. Oh, it's moved on now.
Oh,
actually.
okay. Yep, there we go.
There you go.
Yep, I just saw that. Yep, sorry, I lost where I was for a second. So anyway, yes, I hosted the discussions with the design teams and facilitated essentially what we've got here on this side, which is the evolution of the design to satisfy the concerns from before. So in the first image, we've got the initial design, which I presented before. So we've got the void space in between the pier footings and the angular pier shape. We created an initial design iteration, which led to a more elliptical pier shape, but didn't have the void space between the piers. This again was coming from the structure's point of view, that they wanted a more structurally sound pier with two different pier footings. But to compromise, I facilitated further discussions to create a design to help develop a design which would satisfy the issues mentioned before, which is this final design on the third piece, third box, sorry, which is a single pier element and has elliptical pier shape as well. So with this final design, I was able to present back to the EA this design here, and they were satisfied that the new design removed excess scour potential and also negated any subsequent WFD impacts. Oh, I think it's struggling again, sorry. I've gone through this many times today and this hasn't happened, which is, yeah, as it usually happens. Let me try. Oh. I'm getting a little frozen circle, sorry.
Yeah, we can still hear you, Josh. We're just on the design evolution slide at the minute.
Yeah. Oh, sorry. I think it's switched around. Sorry. Oh no. It's really struggling to do anything. I might have to stop sharing, sorry.
Yeah.
Yeah, my whole computer it's not wanting to open the PowerPoint. I'll close the PowerPoint and reopen it. Apologies.
All right, Josh, take your time there a minute, and then if you're still struggling, we'll come back to yours in a minute, maybe.
Thank you. Okay, what's going on? Okay, I've closed the PowerPoint now, so I'll just reopen that. Okay. I think it's working now. I'll share my screen again. I'll just get back to the slide as well. There we go. Can you see the slide I've got up? Resolution and challenges.
Yes, that's on there now. Yep.
Perfect. Yeah. So I think sorry about that. My last sort of slide, we went through the design evolution process, and I helped facilitate that through my discussions, and I presented this back to the EA to help satisfy the issues I've explained before. So I've just got a graphic here showing essentially my role throughout this process. So starting off, receipt of the EA's concerns, and I use my knowledge to assess these concerns. And then going forward, I was able to communicate this in the discussions with the design teams who were able to develop this design. Then following the development of the latest design, I could present this back to the EA, who essentially gave verbal approval for the consent, which was a great result, considering the difficulties we'd had prior to designing this viaduct. So it didn't come without its challenges, mainly this first bullet point, which is essentially communicating EA requirements to the design team. So getting the design teams to understand what the EA want from the design, as the design team's goal was to design a structure of great structural benefit. However, I essentially resolved this by explaining how we must not only adhere to WFD and HS2 tech standards, but that the EA themselves have a statutory obligation on this matter. So it was critical we did adhere to the EA issues and requirements. kind of following on from that was a challenge of adhering to a range of standards and legislations, HS2 tech standards, the Environment Agency requirements, and the WFD all kind of fed in to inform the design. However, it was a struggle at first to kind of balance these at the same time. However, I was able to overcome this by researching each standard and gaining a good understanding of each standard and of each legislation before informing the design teams of the issues. And overall, this resulted in a successful consent application, which we were given to by the Environment Agency. And yeah, that's the end. Thank you for listening, everyone. Any questions, let me know. Yeah, thank you.
Thanks very much, Josh. That was great. Yeah, and got over your technical problem there in the middle. Well done. Carrying on with that. Fantastic. I can't see any questions in the Q&A box that are on here.
Yeah.
So I was just going to maybe go to the judges for the competition, Mike and Anna and Rob, and just see if they had any questions for Josh.
Yeah, I can get if you like it. So I can't work out how to use question and answer things. So that might be why.
I'm quite happy. There you go.
It kind of says it's not open or something like that at the moment. So maybe that's something.
Just about to mention that, yeah.
So I had a question. So I guess kind of given the proximity of the piers to the river, did you do any like hydraulic modelling or anything like that, or how did you evaluate the kind of scour effects and things around the bridge piers?
Yes, so not myself personally, but so we worked also with hydrologists and the hydrogeomorphology team to assess the scour beforehand. Well, beforehand to the point where we assumed the scour would be sort of satisfactory, but the EA didn't. So yeah, it was essentially a combined effort between the different design disciplines, which I was then able to use their input to inform my consent. And thankfully, the EA agreed that based on the new design and with the new modelling of the scour at that location, we could actually consent on that basis.
Okay. I can go again if you like.
Yeah, it's fine with me.
So I guess I'm just interested to know kind of what lessons you learned in the process of this. Like, you know, like what would you do differently next time if you have to do a similar thing again? Like, you know, was it perfect, or kind of was it something which you would do differently?
Yeah, good question. Yeah, far from perfect. And there's definitely I could probably go on for a while about how I'd approach it, but I think the best thing was I sort of did it with this one, as I mentioned in the challenges, that before involving design teams in discussions, I sort of dug down into the EA's concerns and the other like the WFD sort of aspect, but maybe even further before sort of facilitating them discussions, trying to then combine that with what the design teams were looking for. So actually sort of amalgamating their point of view, well, not point of view, their sort of goal in terms of designing it into my research before actually creating these or facilitating these discussions. So I think that'd be quite useful, because I was sort of like a medium between quite a few different parties. So it's always good to have everyone's requirements and everyone's opinion in the box before delving into it. So I think, yeah, that'd be pretty much my difference in approach.
I've got a question, if you don't mind. I'll try and keep it relevant. But you mentioned you had your role was to do with the consent and the construction kind of side of things.
Yeah.
obviously the bank of the river itself is a bit of a bank. If you had any involvement with what the impact of the construction might be on the actual bank, the river, like can you get plants down there, or is your construction methodology not need access to the actual river bed itself?
Yeah, so the construction methodology stuff, that's kind of covered, not under my remit in my team, so I can't really answer that. That's covered by another joint venture. But essentially, we in our consents we do touch upon construction methodology, but we do refer to this other party who involves with the actual construction nature, probably because the scheme and the design of some of these sort of structures are so big that the construction is a whole another aspect when it comes to actually getting the structure on the ground and ensuring the structure, the constructability of it is a sound process. So yeah, I can't really answer that, I'm sorry.
That's good, thank you.
I've got a question around, obviously your focus on in this presentation was on the Environment Agency consenting side of things. I think you mentioned at the start that you also consent for ordinary watercourses.
Yeah, that's
Is
correct.
that right? Yeah. So I was just wondering if the kind of process that you went through and the kind of challenges that you faced in consenting ordinary watercourses was similar or comparable to that you found with main rivers, or if not, kind of how it differed.
Yeah, definitely comparable. So the ordinary watercourses went to the LLFAs for consent, but also IDB operates in that district as well. So they're quite bespoke consents because they're going to these three different parties. But definitely similarities between their sort of requirements and what we need in the consent, but they do have individual sort of requirements. They sometimes come back with extra pieces of information. The Environment Agency looks a lot into WFD. So for the EA consents, we do have to give a large focus to WFD. But for LLFA and IDB, they've got their own sort of specific requirements. So I think, for example, IDB concentrate quite a lot on how it impacts their maintenance schedule. So that's kind of their focus. So yeah, similarities and differences definitely, but they're not too far away in terms of what they're looking for from a consent.
Which is reassuring.
Yeah, yes, definitely.
I have got another question if no one else has got one. I was the same as you, Rob. I couldn't figure out how to put these in the chat, so I don't know whether that's something I'm doing wrong or sorry, in the Q&A. So unless someone stops me, I'll jump in. I was just wondering, with these kind of huge infrastructure projects, I'll try not to be controversial, but often the kind of consenting and kind of delivery programs aren't always quite aligned, and I was wondering how your experience of that on this project, and whether you felt that enough time and I suppose due diligence is given to making sure that all these potential issues, so like, you know, making sure that piers are the correct shape and in the correct location to avoid scar issues down the line, whether you felt that enough kind of time was given to that in the whole process.
Yeah, that's a good question. So to start with, yeah, in terms of like the programs aligning, I think it's an impossible task, to be honest. But the people who work on it do the best they can, and that's what we can do. But from a consenting point of view, in terms of having enough resources and due diligence, I think we're actually sort of the EA and the LLFA and the IDB are so specific about their requirements, and they're happy to tell us when they're not happy with a design of something, that their sort of standpoint on the things, which is like a statutory obligation. It's not, you know, their opinion as such.
Yeah.
Their actual obligation, which is giving us the sort of sorry, that obligation is not forcing us, but but
Yeah.
giving us the time and resources and the appreciation of what our team does to be able to craft these consents to meet the requirements, sort of thing. So
Yeah.
these bodies can actually, yeah, they do have control over what's consented and what isn't. So there isn't many consents where we can, you know, just kind of put half of 75% effort in. We have to put everything in, because as more consents are coming as well, the bodies are learning more and more about what we're consenting on. So they're always intrigued and they're always wanting to ensure that everything they consent is sound in terms of their obligations. So if they say no, then that's our job, that's our challenge to then to
Yeah.
ensure that the consent is fine. So I think, yeah, it sort of a backwards way of answering that, but yeah, I think we are allowed to spend enough on these consents. This consent went on for a very long time, months, weeks, months, kind of thing.
Yeah. That's great. Thanks.
Thank you.
Okay, that was great. Thanks very much, Josh. We'll move on to the next presentation, which is from George, who's going to tell us about hydraulic modelling to investigate flood risk management solutions for a lost river of Sheffield. So we'll hand over to George now.
Hi, everyone. I hope you can see my screen okay.
Yep, can see that, George, and hear you great. So thank you.
Okay. Yep. So hi, I'm George Conyers. I'm a graduate flood risk engineer at Tetra Tech. I started in September 2021. And prior to that, I did an MSc in flood risk management at the University of Hull. And I'm going to talk to you today about one of my first projects that I was a part of, which was hydraulic modelling of a lost river in Sheffield. So this river is called the Bagley Brook. It runs in and out of culvert within Sheffield. And our focus in this project was about a 1.2 kilometre stretch where it starts to enter culvert, as shown in that picture, all the way down to its confluence with the River Don. The main flood risk arising from the site was as a result of gravity locking of the Bagley Brook by the River Don. And the site that we were looking at was an industrial site, which is at risk from a 50% AEP or 1 in 2 year flood event if it was locked by the Don, and a 3.3% AEP if it was a free-flowing River Don and the Bagley Brook. So initially, I started on a hydrological assessment, which was carried out using WinFAP 5 in RefH2. So I used a statistical method in WinFAP and did a GIS assessment of the FEH catchment, and I found that I needed to extend the catchment out to include the last portion. So I increased the size of the catchment. I then upscaled the RefH hydrographs that I got from RefH2 and upscaled them using the derived flows from the statistical method for use in the two-flow hydraulic model that I built. I also applied climate change allowances to that. So that was at the time the allowance for the upper epoch was 40%. So that's what you'll see in some of these slides later on. In terms of the input data, I had a baseline model constructed using lots of different survey data, reports, scans, etc. So one of these you'll see on the left there is a 1949 long section, and on the right you'll see that's a LiDAR scan of part of the culvert, which I used to help me design the culvert within the model. Where possible, I did try to use the most up-to-date information, and so using the most up-to-date information, such as that LiDAR scan, which is really critical, that LiDAR scan, to provide a real detailed view of the network. So I was able to get a good model representing the actual watercourse properly. So in terms of constructing the model, it was constructed in 2Flow. I used shapefile layers created in QGIS, which has a standard naming convention. That's then run through a text file, and that's then run through the 2Flow executable file. So the model I created was a 1D, 2D linked model. So it used that survey data from the other slides for the 1D culvert network. And then for my 2D domain, I then used a 1 meter resolution EA LiDAR. And then I applied OS master mapping to that, which I was able to use for the Manning's roughness to get a good representation of how water would flow over the floodplain. I inserted the hydrological flows that I derived from my hydrological assessment as weighted point and lateral inflows, and that was based on the catchment area. So I think I applied a point inflow at the top of the model of 88% of my derived flow, and then the rest came in as lateral inflow. In terms of the challenges that I faced when modeling this, so to start with, most of that reach was culverted, so 1,150 meters of that 1.2 kilometer stretch of study area was culverted. So we really needed that 2022 data and synthesizing other bits of data that we had to get a good hydrological understanding and hydraulic understanding of the Bagley Brook. We had some challenges in terms of gaps in the survey data. I couldn't find inverts for all the changes in culvert dimension, which is required by 2Flow, and I had to then manually interpolate between those points with the inverts that I had. Again, using a 1949 long profile, everything was in feet and inches, so I had to convert that and then find out where those inverts were in relation to the present day manholes. There's also quite a lot of complex structures within that culvert. For example, one of them was a siphon chamber, which I had to model. And there's no sort of known example of how I would do this. So I had to devise a solution from my own knowledge of hydraulic modeling. And also a further challenge that I encountered was the fact that you've got a sewer pipe running straight through the middle of the chamber. So it was even more complex to find a solution there. And this is just my model that I created. So I created 2 baseline scenarios, one free flowing and one locked, to understand how the River Don impacted on the flows within Bagley Brook. So you can see that in that picture, the 1D domain with the lines is the culverted Bagley Brook, and then a 2D domain over the top to simulate flood flows from surcharging, etc. So my baseline results, this is from my locked 1% AEP plus 40% climate change event. So this is sort of the top end of the events that I ran. In terms of the model calibration, I found that the results and mechanisms were consistent with a report I received from the client. So I'll play this for you now. So you've got surcharging from the far right, moving left from right to left as the culvert fills up from the Don end on the east side to the left on the west side at the inlet. So it starts to back up, surcharging from a siphon chamber on that far right one, back of the site in sort of the middle there, and then Upwell Street is that last left red circle, and then overtopping of an inlet at Chambers Lane is that purple circle. So I'll play that one more time and you get an idea of that culvert filling up from right to left. and surcharging through and overtopping the inlet at the far end. And that was my baseline that I compare against for my option runs, which I'll talk about soon. So the cause of the flooding was, again, gravity locking of the Bagley Brook. I sort of knew that from what I'd heard from the client. And that was also confirmed by the EAA model of the River Don that I ran in Flood Modeler. So I knew that was happening. I also encountered, when I was doing my option runs, that there was poor conveyance within the culvert behind the site, and that's a long profile you're seeing on screen. And that really just shows how low the gradients are there, which is causing that surcharging behind the site. So in terms of my option testing, it was obviously an iterative process. So this image you're seeing on screen is one of the first runs I ran, which is just a pumping station at the downstream end to stop the gravity locking of the culvert. Well, unfortunately, there are really limited options due to this gravity locking in terms of a flood risk solution, and also the urban environment. Very difficult in terms of space constraints for any of the kinds of solutions. So the options I looked at were pumping stations of various number, capacities. I sort of changed the capacities to see how that would impact on the culvert and the flows in this event. Also their location. I looked at pipe upsizing, looking at like pinch points within the network, to try and find a solution with that. And I also tried to use flow control structures and storage structures to find a solution, which was this. So this solution was submitted to planning. It's a pumping station offsite, and you see that in the right image, and that's a 6 cubic pump, which provides flows during a lock scenario of the Bagley Brook. And additionally, developed a diversion channel to an underground storage tank, which has got a volume of 5,600 cubic meters. There's a 300 mil raised culvert entrance, so that stops low flows getting into the tank. So you wouldn't have to pump out the low flows. Those are all just sent downstream. So it's only in the event of a flood where that would be utilised. Also a sluice gate to limit the flows downstream. So the surcharging that was caused at the back of the site was prevented by this, as it was only letting a certain amount of water down during these flood flows. And also a floodgate on the west side of the site to protect from flows from Upwell Street. So those are becoming sort of from the west to the east, down Upwell Street and up to the northeast. In terms of the benefits this gave the area, there was a reduction in flood risk to the site in the 1% AEP and 40% climate change scenario. There's no flooding on site. Reduced flood risk to the businesses to the southwest of the site. So you can see that in the lighter greens and the dark greens in there. That's provided a decrease to the flood depths. Reduction that then causes a reduction in traffic disruptions, so a bit of social benefits, and also council cleanup costs are less because there's less water in the road network. Also, it was environmentally sound, so it was WFD compliant. The pumps that we will use will be fish compatible, so not harm them. And by biodiversity net gain on the wider project. So this is part of a sort of a wider project where we're aiming to get 10% biodiversity net gain. The impact on the Don as well was something we had to consider. So I used a modified version of the Don model that I was given from the EA, and that I modified by applying a pumped flow from our pumping station that I'd created, and I found that there was no issues as a result of that. So that's the end of my presentation. Any questions?
Okay, thanks very much, George. So I think we figured out that the people who are panelists and the judges are unable to add questions into the Q&A, but the audience members can. So there is a question on there from Simon Lewis. Was there any known interaction with the sewer network, and was this considered as part of the flooding assessment?
There was no known sewer interaction that I was aware of. We didn't have the data for the wider surface water network, so unfortunately we weren't able to apply further inflows from the surface water network. But in terms of interaction with sewer, no, there was no interaction with that.
Okay, thanks. There's no other questions in the Q&A chat, so I'll go back again to the judges. Looks like Rob might be coming on with a question.
Yeah, I've got one. Given the watercourse is so culverted and things, what was the reason for choosing 2Flow, which is predominantly the 2D modelling package for overland flow? Well, and I guess how did you model the culvert in 2Flow? Did you use S3 or was it Flood Modeler Pro? I'm just kind of interested in some of the bit more techie details about how your thought process evolved, how you chose 2Flow, and kind of how whether you thought it was appropriate, I guess.
So initially, because I'd got the model from the EA in Flood Modeler. Initially, I tried to create the model in Flood Modeler, but I ran into like a whole host of stability issues, which just kept cropping up, and I couldn't sort it. So
I can imagine, hence my question.
Yeah, so I decided then that 2Flow was probably the better solution. So yeah, the entire network. So the open water section, sort of 50 meters of open water section to start with, is in 1D S3. The entire culvert network is in 1D S3. But I just used the 2D domain for the in 2D to model the overland flows.
And I guess kind of what challenges did you have then with S3 to kind of schematize the complex underground watercourse? But to me, you sort of painted a picture of quite a complex watercourse, and from my days of doing 2Flow, which is a bit dated now, but it's kind of S3 was quite crude in its ability to schematize complex things.
I think the answer to that was I built it up from something very simple to start with. So to start with, I think I only had like 2 sections of that entire culvert, and I slowly built it up, adding more and more detail. And there, from that, I was able to address stability issues and that sort of thing. I think one of the challenges I touched upon was synthesizing that data and getting it into the network, and having to interpolate certain points for because the model just didn't like not having interpolated points. So I had to give it manually calculated points. So I had a spreadsheet up of this is how long the channel is, it's how the change in invert is, and yeah, had to create my own invert levels, and also, as I've touched on, like the siphon chamber as well, had to come up with a solution for that. So I ended up having above, I'll go back on here, so I ended up having 2 channels created. So I have a channel going above this sewer pipe and a channel going below the pipe. And I had to sort of calculate my own invert levels for that, and come up with that solution. So that was quite difficult as well, in terms of building up the network that way.
Okay. My next question is, how did you validate it? How did you calibrate it? And things like that. This particular model, presumably there's not much information, but given your given what you just said, there could be some issues there potentially.
Yeah, in terms of the calibration, as I said in the slides, that I used a report that I received from the client in terms of when flooding occurred during an event, and matched it up to the simulated baseline. I also had a gauge at the top of the network, an EA gauge at the top of the network. So I used that as well in the calibration, to make sure that my model was working correctly.
Yeah, okay, interesting. That's really interesting.
Thanks, Rob. Anna, I see you've come on camera there. Did you have a question you wanted to ask?
Yeah, I've got a question. It's a lot less techy than Rob's. As I'm not a modeler, but I was just interested in, obviously you said that that you put in a pumping station and that was your kind of solution to the problem. I was just wondering kind of the optioneering process that went into that and whether you considered any other options. Just interested in kind of how you arrived at that as the most appropriate solution.
Yeah, in terms of that, I think because of the nature of the flood risk and how the mechanisms behind that flood risk, I was sort of really constrained in terms of what I could do. So, you know, I did try and develop solutions where that wasn't the case and it wasn't completely reliant on pumping. But that was just because of the gravity locking. That was the solution that sort of had to come about as a result.
Yeah, that's great.
Okay, thanks very much, George. I think we'll move on to Josh's presentation now. So if you want to stop sharing, George, and we'll let Josh take over.
Yeah, thank you.
Thank you.
Just quickly put my camera back on. Is my audio all right? Can everyone hear me all right?
Yes. Yep.
Okay, great. Thank you. Let me just share my screen. I've just loaded that up there. As that came up, as that came through.
Yes, that's coming through. Yep, and we can hear you. Over to you then, Josh. Thank you.
Okay, great. Thank you. So, hi everyone. The title of my project is Exploring the Catchment-Wide Implication of Flood Mitigation Optioneering. So just a brief overview of myself. My name is Josh Greener. I'm a wastewater modeler working for RPS Group, and I started in the industry in September 2019. So I'm just coming up to about 3 years in the role that I'm in, and I'm also a graduate member of SciWem. So just a quick breakdown of the key topics I'm going to discuss. I've got 4 main sections to run you through today. I'll be looking at introducing the project, looking into some immediate optioneering considerations, some detailed wider considerations which I've broken down into flooding, surcharge, and CSO spill, and then I've got a section on some personal lessons learned along the way. I haven't got a specific section on key challenges, but when I go through, I'm going to be discussing the key challenges as they come because they're quite relevant to the sections that I'm going to discuss. So just to start off with an introduction. So what is flooding? Google defines flooding as the submergence of normally dry land with a large amount of water. But in reality, I think we all know it's not really that straightforward. We're talking about people's homes being affected, disruption to infrastructure, pollution of watercourse and bathing waters, and damage to ecosystems. There's no real measure to the extent at which flooding is a hindrance to our society. So I've outlined some main flooding mechanisms on my slide, and the ones that I've been particularly focused around with my work has been sewer and property, but then you also have additional mechanisms such as pluvial, river, and coastal, all of which have a direct correlation with intense rainfall overload in the system. And with the drive of climatic warming, the Met Office predicts that storms are going to become more frequent and more intense in the future, which has implications for increased flood risk, meaning that there'll be an increased demand for flood prevention, mitigation, and resolution. So moving on to that, I've got some examples here of frequently used types of options to combat flooding and ones that I've personally done a lot of work with. So we've got things like pipe upsizing, sewer diversions, cut and pump schemes, and offline attenuation tanks. I also just want to mention SUDs as well, so sustainable urban drainage systems, and they take many forms, aiming to utilize green infrastructure to provide storage and slow runoff to ease pressure on the network during intense storm events. I think SUDs are becoming increasingly integrated into the flood schemes, but there seems to be a difficulty that lies with the fact that they aren't as well established as tested options. And I know water companies want solutions that have proven results, which somewhat deters their usage. But hopefully, as they become more trialed and more tested, that'll change in the future. So here's just a basic overview of the methodological approach taken to identify a flood mitigation option. So step 1, you'd obtain a hydraulic model, which is essentially just a big network of manholes, pipes, subcatchments, and key ancillaries for a given area. Step 2, and this is a critical step, is your model confidence assessment. Now, this is essential because you want to ensure your network model is fit for purpose. And that is critical to replicate realistic flood risk and also, more importantly, produce a solution that will provide effective mitigation in reality. So this can be done by looking at flow survey coverage, manhole surveys, and also ADM and telemetry data at key ancillaries. So from there, you can identify your root cause of your flooding for each specific incident. So what's your main cause of your flooding, what's your main mechanism? And then next is your optioneering stage, which I'm not going to go through in too much detail at this stage because the bulk of my next slides cover this, but essentially it's your extensive model testing and selecting the most suitable option, sorry. Once you've selected and tested your option, you can liaise with multidisciplinary teams, i.e. you can get some civils inputs, you can work with surveyors, and you can essentially produce your final outputs, which can include costing estimates and final reports, and then obviously getting your option in the ground if it's successful. So moving on to section 2, optioneering immediate considerations. So when you're selecting the most appropriate mitigation option from a non-hydraulic background, it might seem logical to look at the option that's the most cost effective, maybe the cheapest option, or the one that's the most constructible and easy to install. If you have a bit of a basic understanding of the sewer system, you might think looking at your root cause of flooding, you can work out what seems like the most logical response to your flood risk. So for example, if you had a 500mm pipe that downsized to a 225 pipe and that throttles flow causing your flooding issue, you might just think, okay, can we upsize that sewer? Can that be our main solution? And here why is it important to not just do that and to also consider the wider catchment. So as I mentioned, the wider considerations, I'm going to split into flooding, surcharge and CSO spill. So as I mentioned at the start, this is a process. So for each branch, I've identified key risks and also how I assess these. So starting off with flooding, one key consideration is you've got to be wary when you're looking at options which alter the rate of pass forward flow. So I'm talking about options such as upsizing pipes and diversions, because this can increase or decrease the rate of flow in a particular section of the network. Now that's got the potential to worsen or offset new flooding at low spots in the nearby catchment. So generally the golden rule is your solution cannot worsen performance elsewhere, otherwise it's not successful. So the question is, how would I assess that? So generally I'd run FEH13 design rainfall through a baseline and an option scenario in my network model. And from there I can assess changes in maximum flood volume using something called a level of service assessment. Now all this is in simple terms, it's just a spreadsheet which you put together and you use formulas and lookups. And when you've exported your model results, your level of service sheet will flag up manholes which experience a sizable increase in maximum flood volume or top water level, or any flooding that was not present in the baseline, so any new flooding. So generally the acceptance criteria is up there, and I think this emphasizes the importance of producing a zero detriment solution. So any new flooding or any significant rises in existing flooding are not acceptable. So just to look at an example here, I've essentially got a long section from InfoWorks ICM, which shows generally your sewer level, your top water level, and your ground level. So in this example, you can see that in the upstream section, so I'll just point with my mouse, you've got a few of those manholes upstream, 4 of them experience flooding. And that's because you've got a 500 pipe downsizing to a 225, which I used as my example before. Now I use that for a specific reason. When you look at the solution, which I'm now showing, it seems that when you upsize that 225 to a 500 pipe, it seems that although your top water level upstream is still high, you generally look to have solved your flooding. You're not getting any flooding anymore. So would you then think, okay, that's your job done, you can move on? No, you can't. You've got to look at your level of service assessment, which I mentioned is so important. So for this example, I've run a level of service assessment, which is shown at the spreadsheet at the top. You can see that in the baseline, your maximum flooding was #N8, which means there was none. And in your solution, there's 0.7 meters cubed, which is quite a small increase, but nonetheless, this is a new flooder, which, as I mentioned before in your criteria, you cannot introduce a new flood into the network. That's not acceptable. Now, when I delved into this further into the model, you can see that I've extended my long section downstream. And where that flow is being throttled, you're essentially protecting a low spot there. So when you increase your pipe capacity, you're increasing your pass forward flow, and your top water level subsequently rises downstream, which presents flood risk to this low spot, which is not acceptable. So you might want to potentially look at a different option. In this case, I went on to look at offline storage as the outcome. Just on your second wider consideration, you've got surcharge. So it's always crucial to check for cellar connections in the vicinity of your flooding location. Even a relatively small increase in top water level around any cellars might result in foul flows backing up into a customer's property. So back to that golden rule, your solution cannot cause problems elsewhere. And how do we do this? Your level of service checks will pick that up as well, because they'll pick up top water levels as well as flooding. On to my third and final consideration is the impact on nearby overflows. So again, when you're talking about options which alter the rate of flow, you might increase your pass forward flow, which that example did. And if you've got any sort of overflows downstream, you might see an increase in spill frequency or spill volume. Now, again, generally any increase in spill frequency is not acceptable. And there's currently a big push towards improving river and bathing water health. And the Environment Agency have regulation on spill frequency from overflows, which I think just emphasizes how important it is to push for a more environmentally sustainable solution. So how do we assess that? I use historical rainfall, and I will generally run a time series through your baseline and your option scenarios. Then set up a statistics template in ICM, which counts the frequency of overflow spills across that given year and the volume of spilled flow. I think the key challenge with this is your time series rainfall generally takes quite a while to run through your model, especially if you've got a big model. So depending on the size, you've just got to be wary of time management. You've got to make sure you've got enough time to get those run. So I've just got a quick example here of a CSO spill comparison that I ran for a development impact assessment in Oldham. So as part of the development, a diversion was proposed by the developers just to increase the capacity of the sewer to receive the additional foul flows. When I reviewed that using my level of service checks, I identified that because there was multiple 90-degree bends, it caused an increased flood risk upstream, which I addressed immediately. I basically went back to the developer and said, okay, we've got to address the fact that we're increasing our flood risk. How can we alter that and take it forward? So we all at the diversion, and once that was performed, we then did the CSO spill assessment. So you can see there the frequency for a typical year run did not change. So it was 8 spills per year and it stayed at 8. I did have a slight concern over the spill volume, which did increase slightly by about 6%. And long story short, in terms of the outcome with that, we did a bit of an extensive model research on it. There was a bit of instability in the model. So what we then did was we worked out it probably wasn't going to be that case in terms of volume. And from there, it was generally accepted through the instability and the fact it was a relatively small increase. So that proposal is now accepted and the work for the development is currently under construction. So just onto my last section, lessons learned. So number one, as I mentioned, model confidence is critical. If you're going to be putting a solution in place and you're going to be testing it, you want to make sure your model is actually replicating reality. Otherwise, your solution's not going to work, especially with storage tanks, because it can go either way. You're either going to sell yourself short and not provide enough storage, or you're either going to waste money by providing storage that's not needed. Number two, how options are likely to impact the surrounding catchment / option costs. I think this is just a sort of personal one. Experience and knowledge gained through that. Like for me now, when I'm picking up a flooding assessment, I can immediately rule out options due to my knowledge on what might happen if you implement this option, for example. And that just sort of cuts down time spent on it, improving efficiency, and that's obviously good for the client. Number three, sometimes the obvious option isn't the most viable. I think I've proved that with my example. And then number four, which I think is important, that hopefully there's a bit of a push towards implementing things like SUD schemes and improving bathing water health by cutting down CSO spills. And one other thing I want to mention is that a sort of key thing and a key valuable lesson that I learned was from working in the multidisciplinary teams, so working with civils inputs and surveyors. So working with those backgrounds just allows like a sort of hydraulic modeler like myself to sort of look past the model and what goes on beyond it, which has been very beneficial for my development. Yeah, that's my presentation finished. So thank you for listening. And if you've got any questions, feel free to ask now. Alternatively, you can send me an email later down the line if needs be. Thank you.
Okay, thanks very much for that, Josh. That was very interesting there. Just looking at the question panel. Okay, so we've got a question come through from Alex. How did you identify the model instability, and did you look at resolving it?
So the model instability, how we looked at identifying that was we ran a series of design rainfall through the model. And what you can do there is you've got your different intensities, so your short duration and long duration events. And generally what you'll find is the theme is your short duration events will cause the most flooding and the increased flood risk, higher top water levels, things like that. And generally when you look and you've got a maximum flood volume from maybe a longer duration event, you can sort of look into the model and see what's potentially went wrong, if there's a slight instability in terms of things like head losses. So from there, what I then did was had a bit of a delve into it and looked at things like total head in the sewer, and that's where we identified our instability. And I think we did generally try to address the instability, but because the model was quite sensitive, we didn't want to do anything that would sort of alter the solution or alter anything that would mess with any of the numbers. So we just, in that situation, we took it forward. We thought it was, because we were happy with the level of service checks and the CSO spill frequency assessment.
Great, thanks, Josh. I suppose a question from me about that was between your, your optioneering and your baseline scenario. Did you have to make an allowance to include climate change or any other factors with urban growth and that kind of thing as part of the solution?
Yeah, so it just depends on the type of project you're working on. So with that one being a development impact assessment, you've got to sort of account for the developments being built over time. I think with this one, it's a one that was proposed to start soon, but then you've also got to consider things like how long it'll take to build. So what we did for that was, which I probably should have mentioned, we ran through the option, we ran climate change rainfall, which just generally provides a 10% uplift factor for, I think you're essentially altering the model to suit for 2030. So yeah, it just accounts for potentially what might happen in the future in terms of if you've got sort of more developments in the area, for example, or yeah, just generally what's going to happen in the future.
Oh, yeah, great, thanks. Okay. Are there any other questions from anyone who wants to come off mute and ask Josh anything else about his presentation?
Yeah, I wouldn't mind jumping in if that's all right. Thanks. First of all, thank you. I picked up on a point you mentioned about some of the CSOs. It looks like a lot of like standard data, rainfall data sets, a lot of like best practice. I think we're probably going to that. My question is around CSO spills have been quite high profile recently in public. So have you had to adjust your methodology on account of some of the detrimental effects that the public perceived? Have you made any accommodation for that in your methods?
I think that's just something that we've always sort of been conscious of, especially me myself, coming from a slight environmental background. I think I've always sort of been conscious when I'm optioneering just to make sure, obviously with it being one of our checks as well, we do a level of service to look for flooding, but equally important is with CSO spill assessments. I know there's been a lot of sort of talk in the public, and I know DEFRA have published something recently as well, where they're looking at tackling overflow spill reductions. So I think, yeah, that's definitely something we account for in that we make sure that we're not making any overflows worse. What I would be quite interested in the future is potentially when we do these schemes, can we look at an option which maybe reduces spills in the future? And I think that's just definitely something I would push for. But for the time being, it's sort of just, yeah, your standard checks, making sure that you're obviously not spilling more, you're not causing any detriment to the water courses. And yeah, hopefully in the future that'll evolve.
Thanks.
Great, thanks. Looks like Anna has a question as well.
Yeah, just got a really quick one if you've got time.
Yeah, of course.
I was just wondering a lot. I'm in fluvial, so know nothing about surface water at all. But a lot of the stuff that you're doing seems to be based on spreadsheets and modelling. I was wondering how much ground truthing kind of goes into that optioneering process.
Sorry, what do you mean by ground truthing?
So obviously everything that you're looking at, or that you've shown us that you're looking at, is done through models and kind of, I guess, virtual. So literally going out on the ground and looking at these potential issues on the ground.
Well, we do tend to do a lot of that because just sort of going back to the start, the model confidence stuff, in some instances we might have impermeable area surveys done. So it's important for us to understand how much flow contributes to the system, just to understand things like general flow through your pipes, where your risks will come from. And then also when we get to a stage of optioneering and come up with a solution that we identify as potentially successful, we have a lot of civils input, and we have essentially guys go out on site and they'll look at, is it going to be sort of constructible? Is it going to be doable? What's the sort of general land use like? Have we put it in an area that's going to be applicable, or are we going to be influencing anything like a triple SI site, for example? So I think it sort of comes from start to finish. Generally, you'll go out and look on site because you need to know that your options are going to be viable.
That's great.
Okay, great. I can't see any more questions in the feature there. So thanks very much for that, Josh. if you want to stop sharing your screen, we'll move on to Katrina's presentation. So Katrina's going to tell us about the Wisebeck flood risk assessment. So over to you, Katrina.
Yeah, let me just share screen. Cool, right. So hi, I'm Katerina. I am an assistant flood risk consultant, been here for about a year, and I've done a bit of geography and environment assessment and control degree, and I have expertise in flood risk assessment and consenting. So this presentation will be about a flood risk assessment that I did in Wisebeck, which is in Cambridgeshire. So just a very brief overview when a flood risk assessment is required. So it's when the development is in flood zone 2 or 3, including minor development or changes of use. When the development is more than 1 hectare in size, when there is a change of use in development type and less than 1 hectare, is an area within flood zone 1 and has a critical drainage problem, such as notified by the Environment Agency. It's involved, and flood risk assessment involves looking at all types of flood risk, including fluvial, tidal, surface, etc., and developing a drainage strategy to deal with whatever flood risk there might be on the site. So this particular flood risk is in Wisebeck, so it's 40 miles north of Cambridge, and it's a market town. And I was tasked with creating an FRA in order to assess the flood risk in order to help get planning for this particular site. Some basic site information: the site is 1.78 hectares wide, is located next to the River Tyne, which is a tidal river. It is part of the Wisebeck redevelopment scheme and includes unused land within the town, such as this. And that image just shows like an example of what the plot of what it was going to propose site. And the proposed plan is to develop a new housing, care home, and commercial spaces. You can see that in the image. So the first thing I did is look at the flood risk. So you can see it's in flood zone 3, which means it's in 1 in 200-year flood event, coastal flood event. And it also has surface water flooding, meaning it's at risk of surface water flooding in 1 in 100-year flood event to 1 in 30-year flood event. And Wisebeck is a market town and is located on an island of high ground above the fens, and is risk of history of tidal and surface water flooding. However, it's protected by the tidal Tyne strategy built in 2005, flood defences, which are built to protect up to 1 in 200-year flood event. And this is through floodgates and flood walls, the gates which can be closed when the water reach a certain level. Due to the flood risk of the site and the proposed development classified as vulnerable by the government, the site needs to pass the sequential and exception test, which means it needs to be demonstrated that the flood risk to people and property will be managed, ensuring the safety, development, and sustainability of the site. Okay. So because it's at flood risk, I got product for data from the EA, which was to assess the risk of flooding if existing flood defences were breached or overtopped in any future event. Breaching just means when the flood defence is broken, the water goes under the flood defence or something like that. Overtopping is when the water goes over the flood defence. And I use present day and climate change scenarios for the 1 in 200-year flood event. And compared them for both breaching and overtopping, with the map just showing the climate change scenario for overtopping. So what I did is I just got the topo survey for the site and added the breaching level and just added like say a meter or whatever it is on top of that. And that is how I've got those figures in those tables there. So in order to pass the sequential test, I looked at the local plan input plan and the strategic flood risk assessment and any surface water document, local surface water documents. So it passed the sequential test because it's allocating the local planning as part of the key part of regeneration of the town. In order to pass the exception test, so I need to prove that flood risk to people and property would be managed with wide sustainability benefits to the community and safe for its lifetime without increasing flood risk elsewhere. This was done by making sure that the finished floor levels must be set above the flood depth and include other safety measures such as safe refuge and a means of escape. So because of different types of development on this site, there's different types of safety measures needed. So any sort of housing, residential houses would need to find a place of safety above the breach level, and there could be no sleeping accommodation on the ground floor. Any sort of apartments and ground floor finished floor levels needs to be 5.3 meters or above, 600 millimeters above the breach level. And extra care apartments, which is in plot 5, so it's high risk of flooding. The ground floor will be for less vulnerable uses such as dining room, lounging, and no sleeping accommodation on the ground floor. And any sort of commercial areas, there need to be a place of safety on the upper floors of the building. But of course, there's always remains a residential risk associated with the defences being breached or overtopped. So the outcomes is that I completed the flood risk survey. I was able to prove the site was safe within flood events by passing sequential and exception test. And this document, along with other documents, is currently going through the planning process with the LFFA, and currently the client and some design team are emailing me regarding some design changes to the site, and I'm just helping providing like appropriate location and flood levels to said design. Thank you for listening. Any questions?
Thanks very much, Katrina. There's no questions in the panel here, so I'll go over to the judges and ask if Rob or Mike or Anna have got anything you wanted to ask.
Sorry, just jotting down some scores there while you're finishing off. Just out of interest, how close was the level of the elevation of the proposed development to, I know you mentioned about 600 mil above the breach level. How close was the proposed elevation of the development to that uplift above 600 mil, if you know what I mean?
Oh yeah, so how much it differed from the topo survey. For the site 5, for sort of the areas nearer the river, so the extra care facilities, it was like a meter above, but for the areas further away from the site, there was something like 300 mil or something above it, so it was less, but the apartments were located sort of nearer the flood risk area. Here I'll show you. Yeah, so the apartments were located, this apartments was more at risk, they were higher, and the extra care were more at risk, but then these was less difference between height in this part of the site.
Great, thank you.
Anna, did you have a question as well there?
We're just interested to know what kind of level of engagement you had before. Obviously, you've done all the hydraulic modelling, but what level of engagement you had with kind of the statutory authorities before this was submitted?
Yeah, so there's the documents, so the council documents, but I also contact. So I didn't necessarily contact the statutory bodies, but yeah, I just read all the relevant documents to see what their standard practice was.
Okay.
I think I have a sort of similar question, but perhaps not quite as. So obviously you came up with a series of recommendations as part of the flood risk assessment. I guess I'm sort of wondering kind of how you worked with the client and how you worked with the Environment Agency to make sure that there was still kind of a sound set of commercial things for your client to make sure that actually there's a sound development there still for them, and whether there was a lot of give and take with the parties and things to arrive at a successful risk assessment.
Yeah, so part of it was like contact CA for the product for data, and also to check the appropriate flood levels, and then having to communicate that back to clients saying you know you need to build the building like a meter of 300 millimeters higher just to mitigate this flood risk. Yeah.
And did they like the answer to that, or did you?
I think because the sites are quite at high flood risk, I think they wanted to put. They probably would want the buildings to be lower, but it needed to be at a certain height. So I helped suggest appropriate locations, and yeah.
Okay.
Okay, right. Thanks very much, Katrina. So I think I'll switch my video back on as well now. I think that brings us to the end of the presentations, and there were 4, very interesting and varied presentations there. So the judges have now got to just go and deliberate offline for a moment or two, and come back and make a difficult decision there about who they think our winner should be this evening. So yeah, thanks again for the presenters. I'll let Mike, Anna, and Rob just drop off to do their deliberations, and for the rest of the people who are on the call, I was going to just quickly go through routes to SciWem membership. So we'll plug the gap that we've got there, and then we'll come back in 5 or 10 minutes with Rob and Mike and Anna to announce our winner. Okay, I'll share my screen. Hopefully you can see my presentation and slides there. So I think hopefully if you're on the call here, you're aware of the benefits of joining SciWem, but and becoming a member. So yeah, there's some items on here, allows you to develop your expertise and earning potential, broaden your horizons and join in the debate with members, helps you to build your professional network, helps you to engage and advocate for SciWem, and it's a recognition of your professional competence. So the different levels of membership that SciWem have. So first of all, member. So what do you need to become a member of SciWem? You need an honours degree or a NEBOSH diploma in environmental management, demonstrable postgraduate experience in the water or environmental management space over a minimum of 2 years. You can submit a copy of your most up-to-date CV, relevant certificates signed by your sponsors, and submit 2 sponsors letters from people who are suitably chartered, who can review and sign off your application, and complete a 500-word report which details the skills and the knowledge that you have gained during your career. So Next level of membership, technician membership. So who can apply for this? People who've got 3 to 5 years of practical experience, which has been gained through an apprenticeship or having completed a relevant environmental NEBOSH environmental management course. And how do you do it? Submit a copy of your most up-to-date CV with a 1,000-word career overview report, copy of your CPD record, copy of academic certificates, provide a list of the training you've completed. Again, you need the sponsors' letters, one of which must be chartered with SciWem, and a 4,000-word mandatory competences report. But if you've completed the NEBOSH, then you're not required to do that one. Graduate membership of SciWem. So who can do this? People with an honours degree or equivalent and an interest in working in the water and environmental space. Why would you do that? So promote your expertise using internationally recognised designation, graduate member of SciWem, get access to the support network of professionals, lets you kickstart your career with access to practical resources and a range of content and services that help you meet and support your development needs. And how do you go about it? You submit a copy of your CV, copy of your degree certificate, and a copy of your degree transcript to become a graduate member. Next level of membership, become an environmental partner. So who is this open to? Anyone, including people who are new to the industry and are working towards becoming a member or a chartered member. Again, why would you do this? Benefits, show your interest in the water and environmental sector, stay abreast of latest guidance and development, access SciWem mentoring to find application sponsors and guidance, and to be able to join a community of like-minded professionals and expand your network. So how do you go about doing this? You create a My SciWem account on the website, fill out the online application with your details and submit the application form. And then chartered membership of SciWem. So who can apply to become a chartered member? People with an honours degree or an equivalent. So without an honours degree, you can apply for chartership through a work-based learning route. Recommendation is that you've got at least 5 years working in the water and environment sector. And how do you go about application for being a chartered member? Is you submit a copy of your most up-to-date CV, submit copies of certificates signed by your sponsors, the 2 sponsors letters again from chartered professionals, one of which needs to be from SciWem, 1,000-word career overview report, submit your training and CPD record, complete a 4,000-word mandatory competency attainment report, and then for work-based learning applicants, you can complete your SciWem work-based learning statement. So that's how you go about achieving those various levels of various grades of SciWem membership. You can find more information about this on SciWem's website. So hopefully you can see me sharing the relevant page there. So it's available at sciwem.org/membership. And this has all the information about the different grades, why people would want to become a member of SciWem. So obviously the reasons I've mentioned a moment ago gives you this globally recognized demonstration of your professionalism and technical abilities. And yeah, you can join at any stage in your career. So grades of membership here. So student member, graduate member, full member, chartered member, and a fellow member. And then again, further benefits of joining SciWem on here. And then on top of that, there's additional registrations you can apply for with the 3 associated professional bodies. So the Engineering Council, which offer the Chartered Engineer Society for the Environment, and the Science Council as well. So all the information available on the SciWEM website. And there are workshops available about fast tracking your route to membership as well. So I'll stop sharing my screen there. Just have a look at the chat function. So I think Barbara has added into the chat here the links to the website I was looking at. The other thing that's been highlighted here, if you refer to the chat panel, is there are some videos on YouTube about how you can progress your membership. And also SciWEM has a YouTube channel where we save the presentations like this one, and the branch presentations are on there, so you can access that for learning and development. What else is there down here? Okay, there's a fast track to membership event taking place on the 17th of August, led by SciWEM Learning and Development, which there's a link to that in the chat function as well. Great, so hopefully that was useful. I don't know if anyone has any questions about that. Whilst we wait for the judges to complete their deliberations and come back to us, so can't see any of them at the minute. Still there. Okay, we'll just sit tight for a minute and wait for the judges to rejoin us.
Richard, is there anything you'd like to say about the Tyne and Humber branch while we're waiting? What benefits people can have from joining your branch, and what you get out of it?
Okay, yeah. So well, the Tyne and Humber branch, we've got quite an active committee. So we're meeting on a monthly basis, putting together a program of events. We've got events scheduled in now for the remainder of this calendar year. If anyone's interested in joining the committee, then you can drop me a message. My contact details are on the SciWEM website, richard.whiteley@ghd.com. Yeah, so we meet on we've been meeting virtually, through COVID, like most people have. We have an event penciled in September where we're going to get together in the real world and host a committee meeting, and then go out for a social event after that. So those monthly meetings, we put together the events calendar, and presentations and CPD events, and I think virtual events have allowed us to expand beyond the geographic sort of boundaries of the Tyne and Humber region. In terms of what I get out of being a member of the SciWEM Tyne and Humber branch is obviously, as the chair, I link up with people from different organisations, different consultants, contractors, people working in client organisations, people that I wouldn't ordinarily come across in my day-to-day work, I suppose. It allows me to network with those people and then learn about different water and environmental projects and things going on in the sector that I don't get involved with in my day-to-day work. So I think it you know, broadens my viewpoint and perspective on the water and environmental sector, allows me to meet new people and learn more about what's going on in the water and environment space. So there's a number of benefits that come with you know, the SciWeb membership. Did I answer your your question there, Barbara? I think, or you've put a thing in the chat there, have you, about the podcast as well? Yeah.
In fact, it was Nikki Roach, wasn't it, who actually set that up? She set it up last year, and I would really advise you to listen to it. It was originally called, it was a different name, Let's Talk WEM. They've now changed it to Planet Possible. But do have a look at the original podcasts and also the latest one. They're really, really interesting. She's had some fantastic speakers, very interesting topics, and it's, you know, it's accessible for people at whatever stage of the career you are at. And of course, a member of the Tyne and Humber branch.
Yes, Nikki, and a past president as well, isn't she?
Yes, absolutely.
Well, there's obviously some serious deliberations going on here, isn't there, amongst the judges? Must be a close call here.
Are there any questions that the attendees would like to ask us? Just use the Q&A.
There's nothing in there at the moment, is there? No.